The first thing that we're going to go over in this lesson is key graphs, and we're going to go over 9 key graphs. And these are going to be the only functions that we cover in this class. I can think of at least 2 more off the top of my head that we're going to go over, but this is where we're going to kind of start. And really, these first 3 are all under the umbrella of a linear function. So to review a little bit of a linear function, when this is in slope-intercept form, you have y or f of x equals mx plus b. This m right here tells you the slope of your line, and this b portion here tells you your y-intercept. So I'm just going to graph some random line right here. For this one here. So it can be any line. You can make a positive one. You can make more shallow slope. This one's a pretty, has a pretty large slope. I don't know what I'm trying to say here. But it is a negative slope since it's going down, right? So then we have identity and constant functions. And these are under that umbrella of a linear function, but they are a specific kind of function. Your identity function here is when you have f of x equals x. So if we're talking about slope and y-intercept here, this line has a slope of 1, since that's the same as 1x. And my y-intercept, or my b, is 0, right? That's the same as x plus 0. So my y-intercept starts at the origin, and then it's going to go up 1 over 1, up 1 over 1, and basically it's just going to move diagonally here. Then if you go in the opposite direction, it goes down 1 to the left 1, down 1, left 1, and so on, and it again moves diagonally. So I'm going to graph this basically from corner to corner through that origin. And there is my identity function. Because when x equals 1, your y also equals 1. When your x equals 4, your y also equals 4. When your x equals -2, your y also equals -2. So it's an identity function because whatever you're plugging in to x right here, that makes your y equal the same thing. Then we have, this one is almost kind of the flip, not really, but kind of your identity function. If we have f of x equals b, now all I have is that y-intercept. So here we have a slope of 0 since I have no x in this. And then my y-intercept is whatever b is. So these are your horizontal lines. So this is going to be crossing right here at B. So hopefully we're pretty familiar with those. We'll see how many of these down here that you're also familiar with. And I'm going to go through these kind of fast, 1, because you can pause and rewind as needed, but 2, because all you really need to know is the general shape that these graphs make. So when you have a square function, just kind of plug in some values. 0 squared is 0. 1 squared is 1. So that's at 1, 1. When you plug in 2, 2 squared is 4. So I'm going to go to 2, 4. -1 squared is also 1. And -2 squared is also 4. So here we have what is called a parabola. Big thing, make sure that is rounded at the bottom. That is a U shape. And what is it, lesson 5 maybe? Somewhere in the middle of this module, we're going to get into more specifically how to graph these and graphing all different types and different forms. Then your cubic is if you have 0 cubed, that is 0. 1 cubed is 1. 2 cubed would be all the way up here at 8. -1 cubed is -1, and 2 cubed would be all the way down here at -8. So this one here kind of snakes. It kind of makes, everybody calls it an S. It's not really an S, but it is curvy right there. Okay, then you have a square root function. Now we know from square roots that we can't have negatives. That's part of our mathematical commandments last lesson. So all of these negative values right here, it's not going to touch, but you can put in 0. The square root of 0 is 0. The square root of 1 is 1. The square root of 4 is 2. I call these your eyebrow function. Starts here, and then it kind of just keeps going forever in that direction, and it increases very, very slowly. Your cubic root function, the cubic root of 0 is 0. The cubic root of 1 is 1. And then for the next point here for 2, you'd have to do the cubic root of 8 all the way down here is 2. So then the cubic root of -1 is -1. And then the cubic root of -8 would be 2. So this one snakes like this one, kind of curvy and S, but it's kind of on its side. Something like that. Now, reciprocal functions is considered your most basic rational function. In one lesson, we had to state the domain and range of reciprocal functions, and it has asymptotes. So this one here has an asymptote at x equals 0. And when I did that dashed line, I'm doing it, it's a dashed line because it's imaginary, and I'm doing it in red because it's not really part of our graph. I am doing it a little bit to the left, but that is actually on that y-axis. I'm just doing it a little bit to the left so we can see it. And then I also have one right here at y equals 0. So dashed lines at y equals 0. And if I plug in 1, 1 over 1 is 1. And if you almost notice, these are all at 1, 1 so far. And if I plug in a -1, 1 over -1 is -1. So this one will be here at 1, 1, and then it's going to get closer to that asymptote, but not touch it. And then it's going to do the same thing here. It's going to get closer to that asymptote, but not touch it. And then here at -1, -1, it's going to do the same thing. It's going to get closer to this asymptote and closer to this asymptote. So the graph is just those blue lines there, but those asymptotes help us craft that. And then absolute value. What do we know about absolute values? Absolute value is the distance from 0, and distance is always positive. So I'm going to have nothing down here with a negative y. So if you plug in 1, the absolute value of 1 is 1. I guess we should start at 0, right? The absolute value of 0 is 0. The absolute value of 2 is 2. The absolute value of 3 is 3. Absolute value of 4 is 4. And the absolute value of 5 is 5. So it looks very similar to this one so far, where it's going up 1 over 1 and just moving there diagonally. But now instead of continuing on down here, when I plug in negative numbers, we get positive values. The absolute value of -1 is still positive 1. The absolute value of -2 is 2. Absolute value of -3 is 3. Absolute value of -4 is 4. And absolute value of 5, or -5, is -5. So this one here, all of your absolute value graphs are going to make a V. Now, again, I went fast with these because honestly, you can rewind and pause. But what we need to know about these is just the general shape. You need to know that your square function or your x squared is a U shape. It's a parabola. You need to know that your cubic function or your x cubed makes this type of graph right here, this type of shape. Your square root function or the square root of x, I call this your eyebrow function. It has a starting point and then it keeps going infinitely in only one direction, right? Then your cubic root looks like this one, but over here on the side, this one's definitely more S-like. Your reciprocal function have these two opposite, I don't know, shapes, boomerangs, if you want to call them. And then your absolute value or the absolute value of x makes a v. So you just need to know the general shape these graphs make. Also, if you're ever curious about them, just graph them. I'm going to graph all of these really quickly. If you don't want to see me graph them, just kind of move on to the next video. But you can just put in x squared. I'm going to go zoom 6 for a standard. And you can see there is your U-shaped parabola. If I change this to an x cubed, there is our squiggle for an x cubed. The square root of x is your eyebrow function. The cubic root, to get cubic, I'm going to go math. And then it's number 4 right here. The cubic root of x. Kind of looks S-like. Your reciprocal function, we have 1 divided by x. And then lastly, absolute value. For absolute value, we'll go to math. And we'll come over here to num for numbers. And abs stands for absolute value. So the absolute value of x. And there is our v. So if you ever forget what these look like, simply graph them, put them in your graphing calculator, but we're looking for general shapes. U, squiggle, eyebrow, S, boomerangs, V.